All right, to continue on, I was just saying aldosterone is going to cause the sodium to be reabsorbed or resorbed right back into the bloodstream. So as the sodium is pulled out into the interstitial spaces here, it's then going to get more and more concentrated. So as more and more sodium exits, this concentration is going to cause more and more water to be pulled out as it goes up the ascending limb. Now, as those materials exit the nephron tubule, we now are going to have them resorbed right back into the bloodstream. So that's going to then be how we pull those materials back out so we don't lose them in high concentrations in our urinary output. Now, as we go on to the distal convoluted tubule, here's where antidiuretic hormone is going to have its major effect. It's going to affect this region and even the initial part of the collecting duct. There's two types of nephrons. The two types of nephrons are named based on their location. So we have some that are about 2/3 distributed into the cortex or the outer layer, so we call those cortical nephrons. Then we have about a 1/3 distribution in the cortex and about 2/3 of it in the medulla, and so we call those juxtamedullary nephrons. And it's these two types of nephrons, they're located all along this peripheral edge of the renal cortex, which is the outside layer, and this renal medulla on the inside layer. So depending on how they're split between there is going to depend on what name we give those. So if we were saying like a cortical nephron, well, about 2/3 of it is in the cortex, about 1/3 of it is in the medulla. And so at this point, we're still going to be pulling water out of the filtrate, but once it goes about into the medulla the medulla region, now we're going to call that urine instead. I probably can't see that, can you? Now you can see it maybe. Now it's technically urine because we're not going to resorb any more materials out of it. So what are some of the materials we don't want to lose out in our urine, in our output? In other words, what's the good materials we want to resorb? We want to resorb our electrolytes, the majority of our water, almost all of our nutrient molecules that we've put through the digestive system. We don't want to lose it into the external environment in urine. So our stuff like our small sugar molecules, like glucose, our monosaccharides, stuff like our amino acids, which were the building blocks of our proteins, even our fatty acids and some of the small lipid molecules we don't want to lose. So these are very important to be resorbed back into the circulatory system through this complex capillary system that surrounds all this area. If you look at your pictures in the books, there are some wonderful pictures with the capillary system involved. Where am I drawing? I've left it out so that you can see it more efficiently. When we look, we produce somewhere between about 1-2 liters of urine a day. Most of us produce more or less depending on our activities. When we are doing a lot of exercise and we're slightly dehydrated, we'll produce lesser amounts. If we produce too low amounts or extremes, almost no urine or what we call anuria, it can be quite debilitating to our system. But the bad products that we've got to get out are our nitrogen-based wastes. So when we look, our nitrogen-based wastes include everything from urea, uric acid, which all these contain nitrogen products. And of course ammonia, which we have to convert in our bodies so that it has less toxic effects. So whenever we're talking about nitrogenous wastes, these are usually the three biggies that we are including there. So that concludes my urinary system. And next we will begin on the reproductive system.